Hi guys, Mr. Prowse here. In today's lesson, we're going to be dealing with some index laws. So hopefully you should have already done index laws when you're dealing with multiplication. So when you're multiplying, you have to add powers, and when you're dividing, you have to subtract powers. But today we're going to go a little bit further. We're going to be dealing with a power of a power and the zero power or the zero index, the same thing. Index power, same thing. Okay, so some words to remember firstly. So what does it mean by a power of a power? Well, it's pretty much just meaning that when you have some sort of term like 3, there's some sort of base, and it's being powered, but then it's also being powered again. So this idea of a power of a power. So you can pretty much see two powers right next to each other like that. So that's what it means by power of a power. Okay, so a few rules to remember. So when you're dealing with this power of a power, you need to multiply these powers together. So that's a bit of the rule of thumb. So see here, we've got our base of 3. Notice the base does not change. It stays a 3. But your 5 and your 2 will multiply to give you a power of 10. So that's pretty much this in a nutshell. Okay, so the next one I want to deal with is this this zero index or this zero power. So when you're dealing with a power of 0, as you can see here, power of 0, pretty much anything to the power of 0 equals 1. So some random number x, if you power it to 0, it's always going to be 1. It doesn't matter what that x secretly is. Another one here, 400 lots of xy. So that's going to be some big number, I assume. We don't know what x and y are. But if I power all that to 0, it's still going to be 1. So that's the idea. So anything to the power of 0 equals 1. Now, that may seem pretty basic, but there are some harder examples that I want us to decipher. Okay, so first up is this one. 5 times x to the power of 0. So here, I think to myself, well, my power of 0 only affects this x. Notice this 5 is not powered to the 0. This 5 could have a power of 1. So it's only the x that's powered to 0, so therefore only the x changes to a 1. The 5 stays, the 5's next to it, so it's timesing. So 5 times 1 equals 5, final answer. So it's really important to understand that this power of 0 only affects what it's next to. We'll get to some, I agree, you're thinking, hang on, well, what about this 0 here? This 0, because of these brackets kind of combine everything in here together, and all of it is powered to 0. So the brackets do make a big difference. So really be in mind whether they've got brackets or not. So here, no brackets, so only that goes to be to only x to the power of 0 turns to 1. So therefore, it's going to be 5 multiplied by 1, and your last final answer is a 5. Okay, moving on. So the next one is this sort of situation. So this is a bit of a trickier sort of one, and the reason is because this 2 is powering this whole bracket because of these brackets. It's really important to understand how these brackets work. Okay, so that means that our 2 is literally going to be powering the 3 and the x. So let's think, how does that work? Okay, so if we power the 3 to the power of 2, it looks like that. And if we power this x to the power of 2, well, it's already got a power. So power of a power, what do we do with these two numbers? We multiply them to get that 20. So then we can simplify it because 3 to the power of 2 is 3 times itself, which gives you a 9. So we do want to simplify these nice simple ones to make a nice whole number like a 9. Okay, so moving on. We've got this sort of situation. Okay, so here, this 2, remember, affects the whole bracket. So everything inside the bracket. But the 6 is definitely not inside. So the 2 affects this. This is a power of another power. So they multiply together to give x to the power of 10. However, the 6 is not powered. So literally nothing happens to that 6. It stays a 6. So it's really important to see that the 2 only affects the bracket. So therefore the 6 will not change. And the x will go to the power of 10. Question 4, we're dealing with a 2 that's powering a whole fraction. So that 2 has to go to each part of this fraction, so those two things. So 4 to the power of 2, that's 4 times itself, which is going to give you a 16. And then lastly, the 2 applies to this bottom part here, but it's already got a power. So it is a power of a power. So you multiply those things together. So 3 times 2 gives you a power of 6. So there's your final answer, 16 over x to the power of 6. Make sure stuff up the top stays up the top, stuff down the bottom stays down the bottom. Okay, good luck with the exercise. The questions should be relatively similar to this. Make sure you are checking your answers. See ya.